Hi Drew, how you doing?
I'm doing great. Day one of DevCon almost. And,
Yeah,
feeling good. Yeah.
I'm glad. We are here at the DVT Summit, the first official DVT Summit. So I'm really excited to have a little chat with Drew here from Commit Boost. Commit Boost is working on some really interesting stuff. So yeah, maybe you can just do a little introduction and we can get going.
Yeah. Appreciate it, and thank you for having us here. You guys have a beautiful view out the venue too. So it's been awesome to meet the community and get to know some folks here that talked online with for a long time. But yeah, name's Drew Vanwerf. I've been in Ethereum since 2016, and earlier this year left some roles. I guess it was crypto, but TradFi, but at a hedge fund to build something in Ethereum.
Nice.
And I was super excited about this question that I had been asking myself for half a year, and it was, how do we use Ethereum's decentralized validator set in a way that we haven't historically thought about? And started to realize that we needed some infrastructure to do that, and this is where Commit Boost was born out of, and felt really passionately that this part of the tech stack should be a pure public good, no monetization, no token. And so went down the ambitious path of, without venture funding or anything, trying to get this thing going. And even today, just some of the things the SSV team, they've talked about with me, it's just astounding to see the disconnect between what you see on Twitter about Ethereum and then what you see with these teams around Ethereum, the 70 plus teams now that support Commit Boost.
Amazing.
And my excitement to move forward around that. So
Beautiful.
again, appreciate you.
Yeah, oh, big pleasure, big pleasure. I think SSV is also a public good,
Yeah.
and the SSV DAO, really wants to support, things that are good for Ethereum. So as DVT, so Commit Boost and the other really interesting things. So I think let's just jump right in. What is Commit Boost? What are validator commitments? Can you just explain to our audience perhaps, why it's important and how it works?
Yeah, maybe the best way to contextualize this is to think about it in today's market structure and the context we have. So 95+% of the Ethereum network runs this software called MedBoost. And when we say MedBoost, it's really two pieces, but what it actually is, we think of it as one piece, but what it actually is two pieces. It's a software or a sidecar that validators run, and it's a protocol that standardizes how validators speak to relays and relays to validators and relays to builders. And it is the pipeline of how blocks are constructed. Commit Boost is a software validators run. It isn't a protocol. And the challenge we started to see is that today when validators run MedBoost, and this isn't against MedBoost, it's just the reality of the market structure, they essentially give one commitment. And it's builder, build my block in the most profitable way,
Right.
relay, find that for me. But when they do that, they give up all autonomy around how their block is constructed, which means in the end, the builders sort of determine, as long as they pay you a lot of money, they determine how the block is constructed, I guess is the best way to think about it. And so what we've thought about is commitments are conditions and constraints validators can put within their block that builders must follow. It gives them a rule set. Hey, here's a template that you must fill in the most profitable way still, but you must follow these rules. And these commitments come in a bunch of different flavors. Hot topic of the day is pre-confirmations, but you could think of inclusion lists out of protocol as one of those. So do not censor my block. You can think about different things with blob management. There's a whole host of ideas. And in some of Vitalik's recent research, he even talked about validators running under types of software, things like that. So it's interesting to tap into that. But yeah, at its core, Commit Boost is a new sidecar that validators will run, and it allows them, without running other sidecars, to be able to start to say, here's a constraint in my block, here's another constraint in my block, here's another constraint in my block, to downstream participants that, and those are the rules they must follow.
I see.
And the difference between Commit Boost and some of the other things that are out there is Commit Boost is just standardizing that last mile communication, and then it gives you tool sets to manage risk. The idea is create one standard that all these teams building these constraints can build on top of, and and then validators can speak to them through that language. And so think of it kind of like an app store. Commit Boost is an app store validators launch, and then they can opt into these different apps, which are the conditions constraints around their block.
Ah, that's interesting. So instead of, for example, running many different like layers of software, there's more like a framework, and you can kind of pick and choose
Exactly.
the way that you want to, build blocks or have your validator build blocks.
Yep, exactly.
That's very interesting.
Yeah.
So what do you? So where are we now, like in the roadmap and stuff like that? If it's, I mean, I know Commit Boost is, quite a newish project.
Yeah,
There's
it
lots
is.
of research and stuff. Like definitely a hot topic right now.
Yeah.
So perhaps you can just fill us in a little bit on that.
Yeah. So we started this earlier this year. First post I think was in May on ETH Research, and suckered some volunteers to help develop it. But since then we've been developing, and for core functionality plus PBS, so essentially backwards compatibility. So the same thing as you get today with running Mev Boost. We have other bells and whistles, but that has completed its audits, and there are already teams running in production. Throughout the course of testing, we had 300,000 plus validators running Husky from 15 to 20 teams that we are aware of. And the next phase for us is outside of just the Mev Boost type block construction that we know today. There's an additional feature we're getting audited now to make other commitments, and other commitments aren't ready yet anyways, so you're not lagging. But the idea for us was get backwards compatibility. People have to run a new sidecar. They have to get comfortable with it. I'm sure there are things that go wrong. Test it, and then as new commitments come along, we're ready to go. And so by end of year, we'll have a fully functioning Commit Boost, hopefully with adoption across a whole variety of both solo stakers, but also sophisticated actors or professional stakers by year end.
Okay, that's very interesting. So where do you kind of see like the intersection of Commit Boost and DVT, or like pre-confirmations and DVT?
Yeah, one of my North Stars was get Vitalik to run Commit Boost. Today, yeah, he stakes, he doesn't actually run Mev Boost. And so with that North Star in mind, the main thing is, can we actually increase the ease of staking for, that's improving decentralization? So the question could be, can we improve DVT? Like as one question. Another question is, can we actually put solo stakers in a better position than sophisticated stakers? It's like another question I've asked. Like, can you build these conditions and constraints in a way that sophisticated actors can't generate the yield unless they're solo stakers? Things like that are the ideas. But when we started talking about the DVT side specifically, today there are challenges with DVT and its integration within Mev Boost. And so even just thinking about day one backwards compatibility, the thing we've been exploring with SSV and DVT more generally is there a way to adjust the way Commit Boost and DVT interacts to improve the way SSV clusters can operate in a PBS pipeline? And so that's our initial type of research that we're working through. And we think we have some things, particularly around latency and risk mitigation of missing a slot, that we think we achieve. And then the next phase is, let's just get it compatible. I'm going to skip all the technical details, but even the types of signatures that are used for these other conditions constraints, we're going to have to make changes to SSV and Commit Boost and the broader ecosystem to get that to happen. And so, focusing on that as a next phase for us.
Cool. Yeah, it definitely sounds like it's quite a road that needs to be walked in order to enable this kind of technology.
Yeah.
Very interesting. So we realized that some of the the commitments that are being the most recent commitments, or the most, how shall I say, popular commitments at the moment, are pre-confirmations.
Yeah, hot topic.
What does that mean? I understand to an extent that you can, for example, look at an L2 and say, we will be able to handle a certain amount of your transactions or something like that. So can you maybe explain that dynamic a bit?
Yeah, no, definitely. And we think about this with Commit Boost. Commit Boost is a software validators run, and then people build these pre-confirmation protocols on top. And right now, I don't know the latest, but there's 5 or 6 teams that are all vying for the pre-confirmation of choice across Ethereum. But in essence, when you think about it as a condition and constraint within block construction, a pre-confirmation is when a validator of a future slot today confirms that a transaction will be included.
I see.
And so what this looks like in practice is when you run commit boost plus one of these pre-comps apps or modules, you're essentially saying, if now, but I'm a proposer in the future, someone says, I want a transaction to be included at some point in time, I say, I will make sure it gets included. And so what it provides from a UX perspective is, you think about Solana, they build these blocks in, I think they're 250 millisecond increments. This is what Ethereum can start providing. And so instead of a block just being constructed throughout the 12-second period or whatever it is,
Oh, I see.
it's actually happening by the millisecond. And so you issue a pre-conf, 50 milliseconds later, you receive receipt that it will be included at some point in time. Now that becomes part of the block. And from a practical perspective, what that means is when that proposer that sold the pre-conf previously, it's now his turn to stack the block. When he's communicating downstream through commit boost, it'll essentially say, by the way, build my block, but you must include this. And so they'll get the header plus that included. And so
I see. So from the validator perspective, is that also a way to perhaps increase your rewards by doing pre-conf? Like, how does that system work versus MEV?
Yep. Yeah, there's estimations by various teams that are out there. They range. High end is probably like 2.5%, so almost doubling.
Yeah, that's wild.
Today's Ethereum yield. I think everyone kind of agrees these are mostly theoretical until we see in practice. But if you use traditional commodity markets, which we've seen develop over centuries of time, this is a general direction that they've all headed for a lot of reasons. And somewhat touched on it earlier, but validation in general is somewhat of a commodity. And the best way to change your service from a commodity to value add is to make sure you're providing services and goods for the end consumers of your product. And so I very much see pre-comps as a UX improvement for Ethereum users, and therefore, likely a higher yield or a service people are willing to pay for in the future. And so still TBD on APY increases,
for sure.
but there's plenty of history that shows.
Is there anything else you'd like to add?
No, I just appreciate the community and its embracing of this, and I'm hopeful not only the concept and what you guys talked about today about having foundation and things. In my mind, a public good and decentralization isn't just making it free for all to use, but there are so many decisions beyond that as you make these decisions, you tie your hands behind your back in some sense. It's much easier just to raise venture funding, like you do these things. And so I very much appreciate SSV stepping up and helping us in our journey and being part of that.
Of course. Thank you very much. Yeah, thank you so much for being here. Thank you for also giving your talk earlier. Really, really insightful. I'm still trying to wrap my head around it a bit more. It seems like a very necessary but quite complex line of work. So good luck to you, sir.
Thank you. I appreciate it. Thank you for having me.
Beautiful. Thank you for being here, and we will see you all later. Thank you so much.